Hello! Before we start, I hope you all received the link to the instructions. If you haven't, go to this link and follow the README to set up your phone for some interactive exercises. The link is also in the Hopin and Slack chats. By the end, you should have a new app installed called Pitch Black on your home screen, and the ability to triple-click on the home or side button to turn VoiceOver on and off. Let's get started. Hello, my name is Leia, and I recently joined SpeechBlubs as an iOS engineer. I am a longtime contributor to Brave Angelic, and due to COVID, I'm currently taking a break from my master's program in Innovation Design Engineering, where my thesis project is focused on helping blind musicians learn music. During this time, I've learned a lot about how accessibility software works in the wild, and got to understand how important and meaningful the work is. At the same time, this experience has also highlighted some interesting challenges and personal biases in creating screen-based interfaces that I never considered before. So today, I'd like to share what I learned. We have a lot to cover today. First, we're going to take a closer look at what it's like to be on the other side of accessibility software, not implementing it, but experiencing it. We're going to learn how to use the iPhone in VoiceOver mode and see what a fundamentally different device it becomes. We'll talk about two common issues that many blind people have experienced that are very easy to fix, and then some trickier ones that require some out-of-the-apple-box thinking. Lastly, I'll try to convince you that paying attention to accessibility is an investment in your future. Before I begin, I really want to thank Scott Chesworth and Kevin Satizabal, both amazing musicians and human beings who have patiently answered all of my questions and whose help with my thesis and this talk has been invaluable. There are around 300 million people in the world who are visually impaired, and about 40 million who are legally blind. And while an iPhone might look inaccessible for a blind person at first, it was actually a pretty revolutionary device that allowed blind people to ditch a whole lot of accessibility gadgets and folded them all into one device, like telling time and navigating, understanding colors, taking notes. It was a real game changer that enabled blind people to have more autonomy over their lives. One of the most important things I've learned is that when you're blind, especially when you're born blind, you experience the world in a completely different way than a sighted person does. Here's an example. Imagine you're blind and you're playing in an orchestra, but you're not able to see the conductor. You won't know where to start, how fast to go, if you're supposed to start speeding up or playing louder. It's a huge challenge. So a professor at the UCL tried to bridge this gap by providing a haptic device that would translate the conductor's movement onto a person's chest. Basically, you would get to feel this. And while it worked really well for people who could see, it was actually a complete failure for the blind musician. Because if you've never seen a conductor move, translating the movement into vibrations doesn't do you any good, because you have no frame of reference for that experience. So translating what we see into another sense doesn't really work, because the mental model for the experience simply doesn't exist. Similarly, the mental model of using a touchscreen visually doesn't exist either. That means that a blind person uses the iPhone in a completely different way than a sighted person does. But you don't really get the difference until you try it. So today, we're going to try it together. And as a side note, this talk won't teach you the nitty-gritty of how to use the UX accessibility protocol. I really recommend that you watch John Fox's or Matthew Bishop's excellent talks from yesterday to learn about that. This talk will, however, allow you to experience the iPhone in accessibility mode yourself, and hopefully help you understand some of the benefits and shortcomings of actually using the accessibility features so that you can approach accessibility with a better informed mindset. So how do we use the iPhone when it's pitch black? A blind user operates the iPhone with VoiceOver, Apple's screen reading software that's been included with the Mac since 2005 and shipped with the iPhone since 3GS. In general, Apple has a long-standing commitment with accessibility. They maintain really comprehensive guidelines. They always have at least one major talk at WWDC dedicated to accessibility and how to implement new features. And it is due to VoiceOver that many blind people actually choose the iPhone over an Android and its talkback equivalent. VoiceOver is really well thought through, it's reliable, and it's standardized. It's a great piece of software. So let's give it a try. Turn VoiceOver on by triple pressing the side or home button. And if that's not working, follow this link and go through the instructions. Here's an example of what happens.
Calendar, Sunday, May 3rd. Photos. Double tap to open. Camera, clock, app, caps, track, fix.
Instead of communicating what's on the screen through graphics, it tries to explain the whole screen to me through sounds and haptics. When you can see, it's actually kind of annoying because when VoiceOver is on, it also disables all of the regular interactions you have with your phone that depend on your finger touching certain pictures. But luckily, there's this handy-dandy feature in VoiceOver called the screen curtain that turns your entire screen black. And with VoiceOver on, you can access it by tapping 3 times with 3 fingers anywhere on the screen. It's technically there to save power, but I find it really useful in actually evaluating your accessibility implementation. So let's try to do that right now.
Screen curtain on.
There we go. It feels kind of strange, doesn't it? Now that we're in VoiceOver, we interact with the screen differently. Your main gestures for interactions are flicks, drags, and double taps. A flick and a drag let you navigate the screen and put different accessibility items in focus. A flick is kind of similar to a swipe, except that it's faster and requires you to lift your finger off the screen at the end. Flicking and dragging correspond to 2 different modes of operation: navigate and explore. Flicking left or right lets you go through the accessible elements one by one from left to right and then top to bottom. In this mode, you don't really know where the elements exist on the screen, but you can learn where they're located in relation to each other in a sequence. So let's give it, with VoiceOver and screen curtain on, flick left and right to navigate between different apps on your home screen.
Photos, calendar, Thursday, calendar, photos, camera. Double tap to open.
Explore lets you put your finger on the screen and drag it around to discover elements along the way where they're actually placed on the screen. If you're using an app a lot, Explore is really useful to learn because you'll be able to find the things you want quicker. Let's give that a try right now.
Solo, new tools, pick, solo, new set, tools, news folder, 11 apps, 25 new items. Double tap to open.
The way VoiceOver works is that it scans the screen for accessible elements, and every time you reach one, it becomes focused. When something becomes focused, you'll feel a vibration, hear an ear con, and an announcement describing the element and how to interact with it.
Photos. Double tap to open.
Just like we've learned to associate visual icons with certain actions, there are sounds, ear cons, that do the same. They're not as obvious, but I'm sure you also know a fair few. Like the screenshot or camera sound, or the sound an iPhone makes when it's charging, or when it locks, and obviously the sound of a notification. In VoiceOver, every UI control and their actions have their own sound so that changes of state are properly communicated. For example, this is the sound of dragging on empty space, like at the bottom of the home screen. And this is the sound of a UI alert appearing.
Alert.
For a blind person, these sounds are instrumental for understanding the interface quickly and effectively. Once you have an item in focus, you can double tap anywhere on the screen to select or activate the last focused item, like this.
Finance, health. Double tap to open. Health, summary, heading.
And this is the sound it makes when you make that selection. On top of these 3 common gestures and sounds, there's a whole range of others that super users can learn and master to operate their devices in a manner that's most effective and best suitable for them. In a way, it's kind of like this awesome top secret new language to operate an iPhone without looking. I really recommend checking these out. But now, back to the lesson of the misguided professor. Translating what we see into another sense doesn't really work, because the mental model for the experience simply doesn't exist. In the world of apps, I am sure we've all made a button similar to this one to indicate a menu. And conveniently, Apple makes all UI buttons accessible, so VoiceOver will pick them up. But if we don't set an accessibility label to tell VoiceOver what to call the button, it's going to describe the button through the image name. A lot of times, what ends up happening is this.
Hamburger icon, button.
The image is called a hamburger because the menu icon unintentionally looks very similar to a hamburger. But for a person who's never seen this menu button, comparing it to a hamburger makes no sense, and calling a button a hamburger is profoundly confusing. It's a similar story with asterisks indicating required form fields. Sighted people know what it means through the symbol and color, but a blind person most likely won't. The take-home here is that you should label and describe your UI and interactions in a non-visual way. We really need to be careful not to let our visual bias influence us. When you're a musician, you often learn new music by looking at sheet music. And once you get good enough, you can sight read, which means that you can look at the sheet music and play at the same time. But when you're blind, that's not possible. You learn new music through audio recordings or music braille. Both of these options have a whole bunch of hurdles, but the main difference here is that you always have to read an input, memorize it, and then play it. And this need for memorization is true across the board. You have to memorize the route to the bus stop, how to get around in a building, where things are placed in your spice rack, so you don't actually use cayenne instead of cinnamon. Basically, you have to memorize everything. It's tough work, but you can ease the burden if you keep things consistent, because it becomes part of your muscle memory. But as app developers, we're always adding and changing and deleting things in our apps. That means that if you do a major overhaul of your app's UI, where you've reshuffled the functionality or changed some interactions, that's going to cause a pretty steep learning curve for your blind users. Because once you have something in your muscle memory, it's really hard to change the habit. That is why people who are blind are very, very cautious when upgrading their apps. They don't know what to expect, especially if the thing they have right now is working just fine. So instead of an app update being exciting, it's a cause for anxiety. There are multiple long threads on a website called AppleViz asking whether it's safe to update something or cautioning against updating because things broke. One way to help this transition is to provide as detailed as possible app descriptions with every new version you release and communicate the changes you've made to your users really well. One great benefit of seeing sheet music is that you can immediately glance at the past, the present, and the future of what you're supposed to do, and create this overview of how a piece will flow, how difficult it will be, how it sounds, kind of zooming in and out and seeing the bigger picture. And that's a superpower of vision that no other sense has. It's similar to how you can just look at a piece of software and understand how it works and what you can do with it. But when you're using software as a blind person, you can't create this overview to understand what's possible. And without knowing what's possible, you don't even know what to ask for. Alright, it's time to fire up the pitch black app. It is completely black, so you'll have to use VoiceOver to explore it. I encourage you to grab it at this repo and try it out yourself. But if you can't, I'll go through it with you and try to figure out what this thing is. I'm going to turn on VoiceOver, navigate to the pitch black app, and go through the UI.
Pitch black. Do you love cheese? Switch button. Off. 1930, January. Picker 1. Pick. When's your birthday? €0. Adjustable. Ideal price. Euros? €0. Adjustable. Swipe up or down with one finger to adjust the value. €5. €10. €15. €10. When's your birthday? 1. Picker item. Adjustable. 1 of 31. January. Picker item. Adjustable. 1 of 12. 1930. Picker item. Adjustable. 1 of 81. Find your cheese match. Dimmed. Button.
Huh, okay. Did you get all of that? Reading each UI element one by one makes it really difficult to get the full picture of what's going on. Imagine that instead of blankly exploring what controls are on the screen and trying to piece together what an app does, each screen would proactively tell you about it. Something like this, for example.
Pitch black finds you your perfect cheese. Answer 3 questions to find your match.
It tells us what the main points of the screen are and what actions to take. It tells us what the main points of the screen are and what actions to take. It's simple and to the point, and I don't have to discover the app all on my own. Rather than a description of a specific control, think of this as a description for the screen. This is what is called an auditory overview, a technique that's gaining traction in the human-computer interaction research field for the visually impaired. It's not something Apple recommends, so there's no official way to do this, but you can get around that by posting a notification at an appropriate point. It would be really nice, though, if in the future Apple did give us an option to write descriptions for full screens instead of just controls. The tricky thing here is figuring out how to strike the right balance between how much information we give so that we're informative but not overwhelming. Time to get back to the app. Now that you've explored the UI a bit, let's take a look at what the app actually looks like. It asks you a couple of questions and finds you the perfect cheese match. It uses a switch, a slide, and a picker. And initially, the Find Your Cheese Match button is disabled. VoiceOver will refer to disabled buttons as dimmed, like this.
Find Your Cheese Match. Dimmed. Button.
That's because the form requires you to be a cheese lover and set an ideal price before it can actually calculate your best cheese match. If you were looking at the app, it would be pretty easy to tell what's missing to enable the button. The red highlights make it painfully obvious. There are 2 things that are wrong, and you kind of know how to fix them. But when you can't see, you don't have access to this info. You don't know how many things are wrong, which ones they are, or how to fix them. You kind of have to cycle through them one by one manually and then keep on checking whether the button got enabled to figure it out. And that's another issue. When you can see, it's easy to let you know that a button gets enabled because it turns from being grayed out to blue. Instead of having the user go through each control and check whether the button got enabled themselves, we could post a notification whenever the button changes its state.
Adjustable. Find Your Cheese Match button enabled. €10. €15. €10. €5. Find Your Cheese Match button dimmed.
But that could get pretty annoying, so maybe there's a way that we can use ear cons instead to say when the button turned on or off. But then what if there are multiple buttons? Do we maybe try to use some haptics as well? Or how about 3D audio? Could that help? Maybe. I don't have specific answers to these questions, but I do want to challenge you all to give them a really good thing. Let's do a recap of what we learned. Use VoiceOver and Screen Curtain to properly evaluate your accessibility implementation. Describe elements using a non-visual, action-based language. Write very precise App Store descriptions for every update to reassure your users about how the app works. And try to communicate system status like loading or missing information in text fields through VoiceOver rather than just visuals. At this point, you might be thinking that, this all sounds great, but does it really concern me? And I really want to convince you that it should. How about the warm and fuzzy feelings that you get when you do something good and unselfish for the world? Or maybe the fact that there are around 40 million people in the world who are legally blind. They tend to be overlooked and underserved, so when a good app comes along that is accessible, they'll tend to stick with it and become lifetime customers. Maybe the fact that inclusive design tends to benefit everyone, Similar to code, when you solve the problem for an edge case, you've probably come up with a solution that's better for the whole problem. Designing for the deaf gave us subtitles and closed captioning. Designing for users with poor motor abilities brought us the electric toothbrush. And curb cuts, the OG, originally designed for wheelchair users, are now indispensable for parents with strollers. The last, but not least reason, is that thinking through these problems now is a great investment in your future. Because I believe that the future is screenless, or at least less screenful, for two reasons. Number one, we're actively trying to dial down screen usage because the amount of time we spend glued to our phones has a dramatically negative impact on our physical and mental health. Both Apple and Google have launched initiatives and experiments to improve our digital well-being by helping us reduce the time we spend on our phones. Reason number two is that audio for interaction is gaining a lot of mainstream momentum. Voice assistants are becoming cheaper, better, and more commonplace, with almost 35% of all households in the US having at least one. Kids are treating them as members of the family. And this interaction of talking to an artificial agent at home is helping lift the stigma of talking to a machine in public as well. Isolating text or asking Siri to set timers or reminders, it's faster, more intuitive, and more on demand. Compared to just a few years ago, today there are 700,000 podcasts, with half of the American population listening to at least once a week. More people than ever before are relying on audio for their source of news and entertainment. Instead of vision, information input is shifting towards sound, because processing visual information is an expensive task for the brain. Instead of reading an article that requires your full attention, you can listen to audio while remaining present in your surroundings. Companies like Calm, Curio, and Blinkist already rely entirely on sound as their content delivery mechanism. And when information gets delivered through a sense that uses less of our brain's CPU, it frees us up to do other things at the same time, like commuting, cooking, or exercising. Alongside that trend, we've also seen a shift towards hearables, wearables that you can hear and speak to that don't hijack your eyes, like the AirPods. And while iPhone sales are stagnating, Apple's AirPods sales are getting stronger every year. It's completely normal for someone to spend their entire day with their buds plugged in. And these devices are becoming smarter and smarter. So while we might have thought that the future of augmented reality is visual, it seems likely that audio is a better option, as it integrates more naturally and seamlessly with our environments. This type of mainstream adoption will necessitate a shift towards creating experiences where audio and touch are at the forefront. So I dare to claim that we are headed towards a screenless future, and with it, a screenless UI. What does a sound and touch UI feel like, and how does it behave? By creating a better experience for your existing niche sound and touch users, you might just find some answers to these questions now. So, if for no other reason, make your apps accessible because it's an investment in your future. Thank you. And here are some resources I found really useful in creating this talk.